Hello students, welcome back to the JEE Last Mile Preparation Series 18. Today we will take up questions 35 and 36. But before I do that, by now you already know that I'm Sujata from CBSE NEET JEEchemistry.in and we are bringing you 2 questions every day until April 4th to help students get that extra edge for their JEE chemistry exam preparation. To keep me motivated in this task, please hit the like button and don't forget to subscribe to my channel. Also, please visit my website. The link is in the description below. Let's get started. We continue with inorganic chemistry, and today the 2 questions have been chosen from the topic P block elements. Now, here is question number 35. Let's read the question. Okay, and highlight the important requirements. A gas P is produced when copper reacts with dilute nitric acid. So copper reacting with dilute nitric acid is important. P reacts with oxygen to produce brown fumes of Q. Q, when dissolved in water, produces a strong acid R and you get back the gas P. P, Q, and R are respectively. So here you have 4 options. Okay. So the correct answer would be any one of these 4 options. Right. So let's write down this reaction based on the information conveyed in this question. And then we will get to identify what P, Q, and R are. Okay. So yes. The very first information conveyed is you get a gas P when copper reacts with nitric acid dilute. Okay? You know that when copper reacts with dilute nitric acid is an oxidizing agent. It gets reduced to nitric oxide. Okay? Plus, the other product has to be copper nitrate, and then you also get water. How do you balance this equation? You can try and balance it the usual way, but it may take a long time. And some of you may try to memorize the coefficients for each of these reactants and products. Okay? A very simple way to balance this equation would be to split this into 3 parts. It's called the partial equation method. First, let's write down the reaction concerning the reduction of nitric acid. You get water plus nitric oxide and nascent oxygen is produced. This nascent oxygen reacts with copper to give you copper oxide. Okay. Now let's balance the first equation. You've got 2HNO3, so hydrogen is balanced. 2NO, so nitrogen is balanced. You've got 6 oxygens, 1 plus 2, 3 plus 3, 6. The second equation is balanced, but since you have got 3 oxygens in the first equation, let's multiply the second equation by 3. So that is your modified second equation. Now what about the third equation? That should involve the formation of the salt copper nitrate. You got copper oxide here. So copper oxide will react with nitric acid, a usual reaction between a metal oxide and an acid. You get the salt, copper nitrate, salt, and water. Okay, so since there are 3 copper oxide here, I put 3 here because we don't require copper oxide in this equation. It has to be cancelled, right? And how many moles of nitric acid do we need? We have got 2NO3, so let's write 2 here. Now let's balance the hydrogens and oxygens. Hydrogen is already balanced. Oxygen is 3O plus 3 plus 6, which is 9. Okay, so what we get here is not enough. So let's do, of course, we have to go 3 here. Correct? So 3 copper gets balanced. Once copper is balanced, nitrate ion is 6. So I put 6HNO3, right? And then we can balance hydrogen. So in this manner, we balance all the 3 equations. And now we cancel out common terms. So 3O gets cancelled, 3CuO gets cancelled, right? So now we are left with 3Cu plus 6 plus 2, 8HNO3, giving you 3CuNO3 twice plus 3 plus 1, 4. 4H2O plus 2NO. This is the final equation, final balanced equation. So now we've got the gas P. So we found out the identity of the gas P, which is nitrogen monoxide or nitric oxide. So what is the next thing? Next information conveyed in the question. The gas P combines with oxygen, reacts with oxygen to give you a gas with brown fumes. Now the gas with brown fumes coming from nitric oxide has to be nitrogen dioxide. 2NO plus O2 giving you 2NO2. This has brown fumes. And this is Q. And the last information conveyed is the gas Q reacts with water to produce a strong acid. The strong acid that you get here will be nitric acid plus the gas P. The gas P is what? Nitrogen monoxide or nitric oxide. Right? How do we balance this now? So to balance this, suppose we put 3 here, 3NO2. So this becomes, and then you have 2HNO3, right? So you already have a nitrogen here. So you have 3 nitrogens on this side, and already hydrogen is balanced. Let's look into oxygen. 6 plus 1, 7. 6 plus 1, 7. So this is the identity of R. Okay, so we've got the identities of all the 3 compounds, right? So P, the gas P is nitric oxide or nitrogen monoxide. Q is the brown fuming nitrogen dioxide gas. And R is the strong acid nitric acid. So which option corresponds to this information? It has to be option A. All right. So this question was based on group 15 of the P block elements. Now we move on to question number 36. The correct order of acid strength is, 4 options have been given here. Okay. So now you've got the 4 acids whose strengths are compared are. So let me make a list of them. Are, one is HClO, which is hypochlorous acid. Then you have chlorous acid, chloric acid, and perchloric acid. These are the 4 acids whose strengths have to be compared. Okay? Since we're comparing their acid strength, it depends upon the readiness with which this hydrogen is lost as a proton. Now, HClO4 will fully dissociate. So we are not sure about the strength as yet. We'll analyze it. So let this be H plus and ClO4 minus. This would be H plus ClO3 minus, H plus ClO2 minus, H plus and ClO minus. So all these, what we've written here, namely the hypochlorite ion, the chlorite ion, right? The chlorate ion and the perchlorate ion. All these are conjugate bases. All these are conjugate bases of the respective acids. Okay, so ClO minus is the conjugate base of HClO. Similarly, perchlorate ion is the conjugate base of perchloric acid. Okay, so whichever acid listed here undergoes the forward reaction most readily will be the strongest acid. How do we determine that? We determine that by comparing the stabilities of the conjugate bases. Okay, and it is found that perchlorate ion is the most stabilized because, see, in all these conjugate bases, you have a negative charge. And there are most number of oxygen atoms in perchlorate ion. So there's a great likelihood of this negative charge being delocalized to the greatest extent. Okay, so whichever conjugate base has the most number of oxygen atoms will undergo the greatest delocalization of the negative charge, making it the most stable. So let's analyze the stability of perchlorate ion. Okay, let's write the Lewis structure of perchlorate ion. You have chlorine. You know that chlorine can show expanded octet. So let me show O minus, double bond O, double bond O, and double bond O. So all the 7 valence electrons of chlorine have been utilized. 1, 2, 3, 4, 5, 6, 7. Okay. Now this is the structure of perchlorate ion. Now this negative charge here, okay, is on a 2p orbital of oxygen atom. One of the 2p orbitals of oxygen atom. Okay, this lone pair of electrons. So minus charge implies that there's a lone pair, there are 3 lone pairs of electrons. So one electron has come from an external source. So one of the lone pairs is housed or accommodated in one of the 2p orbitals of oxygen atom. Okay, you know that chlorine has got vacant 3d orbitals. So what can happen? For delocalization to happen, the lone pair of electrons in one of the 2p orbitals of oxygen will have to be accommodated in a vacant 3d orbital of chlorine atom. This type of delocalization, this is called the p pi d pi back bonding. Okay, so this is now going to be accommodated in one of the vacant 3d orbitals on chlorine atom. So we call it as the p pi d pi back bonding. And this overlap, so the overlap of a 3d orbital with a 2p orbital will occur sideways or lateral overlap to form a pi bond. We call it as a p pi d pi back bonding. So because of that, this lone pair of electrons can be accommodated in a 3D orbital. Same thing can happen to any one. So the negative charge is not localized on this oxygen atom. There are 3 other oxygen atoms. So the negative charge could be located on any one of the 4 oxygen atoms, resulting in that many resonance structures. So let me draw the resonance structures of the perchlorate ion. Okay, so one structure has already been drawn. You've got O minus tetrahedral structure. The chlorine atom in the central chlorine atom is sp3 hybridized. The next resonance structure would be, this becomes a double bond. This becomes O minus, double bond O, double bond O. The next would be double bond O, single bond O minus, double bond O. And the last of the resonance structures would be double bond O here and O minus. All right. The other conjugate bases will produce lesser number of resonance structures. ClO3 minus will produce 3 resonance structures, 2 resonance structures, and this will not show resonance. All right. So whichever conjugate base is the most stabilized by delocalization, okay, and that is mainly due to the p pi d pi back bonding. So whichever conjugate base is most stabilized by this method will be the most readily formed, and hence the perchloric acid will be the strongest acid. And perchloric acid is stronger than chloric acid. Both perchloric acid and chloric acid are found to be strong acids. On the other hand, the chlorous acid and the hypochlorous acid are found to be weak acid. They do not dissociate fully into the corresponding ions. All right. So what would be the correct order in question number 36? The correct order would be HClO4 is the strongest, followed by HClO3, followed by HClO2, followed by HClO. The increasing order would be option B. Okay, so this was a question from group 17 of the P block elements chapter. If you found these 2 questions useful, please like the video and don't forget to subscribe to my channel. Also, please visit my website. The link is in the description below. See you tomorrow.